Hello, everyone. My name is Shadab, and I'm thrilled to be speaking at the BIM Coordinator Summit. Today, I'll be sharing insights on solutions to validate models in precast projects. So, without any further ado, let's dive straight into the topic. Before we proceed, I'd like to take a moment and tell you a little bit about myself. I'm a project engineer with Punch Consulting and have been working in the precast design industry for the past 4 years, and I have a bachelor's in civil engineering. Now, let me introduce you to my company, Punch Consulting Engineers. We've been Ireland's leading engineering consultancies with offices in 5 cities and 2 countries with 50 years in consulting business. At Punch Consulting Engineers, we believe in power of collaboration, embracing cutting edge technology and innovation to optimize project outcomes. So, what's a deliverable in terms of precast? In terms of BIM process-based projects. So typically, BIM isn't just limited to any information modeling, but it's information management. It's essentially the information with the 3D geometry, and the outcomes are driven by the model. So whatever information that you have in the model is basically the data that drives the drawings or the outputs or the processes going forward. So typically, in terms of precast, there's a lot of different kind of modules involved, like walls, stairs, columns, beams, and all those other things. And these are to be coordinated with the steel, MEP, and all those fabrication and in situ works. So ideally, on a precast detailing job, there are a number of people working on the model at the same time. Um, so there's difference of opinions, there's different ways of working. Uh, Not everything might be incorrect, but uh, there's sometimes there's lack of consistency that causes issues while you're working on a collaborated model. So like there's incorrect methods of modeling. Someone would just put uh, the panel in this direction and someone would just put it in the other direction. Geometrically, it doesn't make any difference, but when you try to produce that panel, the face, the mold face, the form face, those kind of places are flipped up. So that's something that you need to look out for that. Incorrect copy pasting. So if something works in one project, they would just copy it and paste it here without changing any attributes or anything. Or maybe sometimes it's just like the element is exploded. So it doesn't has any input in it, but it doesn't has any data, but geometrically, when you look at the drawing or when you look at the 3D model, it looks very much correct. So typically, I would be comparing most of the models, like checking the data behind those geometries and all those things. And while working on these kind of geometry comparison things, I realized like most of my time is just spent on matching values. Like if something over here matches with my tables, like for an instance, if I have lifters, the lifters look kind of the same in on the drawings, but when you have the data in the table, it says a different type of lifter or something like that, and then I have to check if the weight of that panel is sufficient. Is I mean the lifters are sufficient for the weight that they need to carry out. So it's like a very much, I would say most BIM coordinators or detailers or engineers coordinating on BIM based projects, or maybe the precast industry in general, they spend a big chunk of their time just basically comparing objects, just comparing drawings with the tables or the outputs or the capabilities. Uh, that's basically like a comparison thing. So I was wondering if I mean like the team in general, like we had a bit of a thought as to like if some we could have some kind of automation in this sense. So what if the drawings we generate could automatically, tell us that this thing is incorrect or this thing is wrong or something like that, based because you have the information in the model. So the model is the geometric data, and the model is filled up with repository, like it has all the lifter and the other attributes in it. So it's essentially easy enough for you to be able to just call out some tables or data templates or the drawing layout templates that look for certain key specific information, and they might be able to mark up something on the drawing itself. So when you generate a drawing or you get a PDF from a technician, it would just automatically highlight stuff that this is wrong or something like that. It's essentially just like adding a code block to the template to look for values that suppose I was looking at the drawing or wall or panel or something like that. I would typically look for those values and just compare it with a printout of a supplier catalog that this matches with this, and that's it. And probably that's something I would use to sign off those units for production. So typically the output would be like the capabilities of lifters. If the technician has modeled the right lifter. By modeling, it doesn't. I don't necessarily mean just putting those lifters in the geometric perspective, but the production codes and the PXML data that needs to be modeled along with as an attribute to that 3D geometry is what we are keen on, because uh, precast is also produced by robots. So these robots are driven by the PXML or unit technique data. And even in case of steel, most of the steel is cut by CNC machines. So you also have the NC data files that are generated from the precast model, from the building information model to and then supplied in the form of a file, in the form of a XML file or PXML or whatever is the machine input required. So it would basically look for capacity of lifters, or maybe sometimes you have a specific size of pallet, like there's the bed that is used to produce those walls, or maybe the truck loading capacity, the truck dimensions or something like that. So you would look that drawing itself would look for things that are not producible or something, and it would just change the presentation of that to a different color, or maybe he's trying to add some words or something like that. And then look for production codes, because this is something that may not be required for production, but in terms of procurement and billing, this is something very essential. Like most accounting firms would have ERP systems, or maybe the precast factory would also have an ERP system to just get the data. And based on these volumes of stuff, they would just order and procure all the fixtures and accessories. And the last is like, I mean, it's not last, but it's just something I usually just have in to see if suppose it's a wall, it needs to have a temporary support. So if that wall has a temporary propping accessory attached to it or not, because sometimes it happens that a technician might just have deleted stuff, or maybe you can't control how the model is being built. If you are a coordinator or something like that, it's on a big project, it's kind of difficult with the number of people involved in it. So you would want to have as many checks as possible to avoid any kind of errors. So the templates would look for the values in it. So that's basically a few key outputs that I could think of at the moment. So at Punch, we use Tekla structures for our precast detailing and coordination things. So even with the steel stuff, we use Tekla, and we have a very nice video with Trimble, when our director talks about how we've brought precast to life with automation and Tekla structures. So I would just talk about a small feature that we kind of used it as a validation tool. Uh, it's the purpose of this feature, this report template, was to generate a report or maybe add a table on the drawing, but we just used it to make help us validate if stuff in the production drawing is correct or not. So if you can see my screen, like with the Tekla structures, we are able to set up model templates files that based on a particular if else logical algorithm, they would like, for an instance, I'll show you how it's done in the next slide. So uh, so this is the output that will come out basically. Like if you look at that, that's a screen grab from a unit drawing. So if you look at those wavy tail long, it says based on that weight of the element, based on the weight of the wall, the technician has provided two lifters in that, and that's the production code and all those things in there. But if, for an instance, the element is heavy, so you need four lifters instead of two, and the lifter type is also different there, or maybe based on the length, if the angles are changing. So based on that, it will look for it'll compare if that passes or not. So if you see there's a red, a similar kind of a symbol to on the first image, on the image of, I don't know if this highlighter pointer will work in this or not, but I'm just trying to point it over here now. So if you see there's a similar sign that says, okay, this is valid because it's passed through the entire validation system. And if you look at the image at the bottom, it says fail for RD24. So just looking at the image, even if it has gone, even if the model is somehow, if you miss out to check in the 3D model, check with the while you're reviewing the model, there's ample chances that when you have too many, when you're overwhelmed with work, you kind of miss out these things. So this is basically just generating drawings, and the drawing themselves tell you that, okay, this stuff is wrong and this stuff is not matching. You need to spend a bit of time to configure all of these automation thing in the model or in the drawing generation module. But once that's done, like you could have a good enough fallback mechanism as to, whatever is being delivered is exactly the 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 kind of thing that the production needs. So here's a few set of just an insight as to how this is done. So if you look at the screenshot here, it's the Tekla template editor. So basically every row is basically like a loop, and it goes through all the fixtures that are in there. So if it's not much clear, but it has like is lifter, then required lifter, provided lifter, and uh, the comment over there in the red. So if an accessory is a lifter and it's provided, I mean, like it'll calculate what lifter is provided. Then what's based on the dimensions and the length and the weight of the unit, it'll calculate what is required. So if the two of those match, then it'll just print off a straight single line or something on the drawing as it's shown in the first image. And if it fails, it'll tell you that it fails and what you need to provide to make it pass. So this just this small bit of a few bits of codes, we've used them on a number of projects now, and like each project has like about 150 to 100 walls on each level, so that saves a lot of time spent by a coordinator or a technician or anyone else manually going through all the drawings. It's not like I'm saying that I shouldn't be checking these in the modeling phase, but it's just a good enough fallback mechanism to arrest all the kind of slippages that you may have. Uh, there's a very interesting argument we've had sometimes as to, like, in terms of automation, like if you know that's wrong and the system is able to identify that that is wrong, why doesn't it rectifies itself? So, at the moment, my experience with Tekla structures is like the models, they operate the drawing. So, if I go to the next slide, based on the model, whatever information you have in the model, that is what drives the geometry and production of the drawings or the PXML or the other datas. So it's a one-way direction flow. Like it's not like the drawings can write back to the model. I'm aware that there's a few tools like plan bar, or maybe then you can just edit the model from the views itself. But ideally what I've seen is it's like in tech class structures, the drawings are generated based on whatever is in the model. I think it goes the same with Revit or something as well. And this is a software limitation, but the other thing is, like, these things could be doctored, you know, not on the model but on the drawing. So if you have an incorrect thing in the model, but the drawing produces it and shows that it's correct, like for an instance, you have two lifters, but the drawing knows that that's wrong and it shows four lifters, which is a good enough work like a fix for that. But the thing is, your model is the main source of information, and your drawings is a distributary. Like it's, if the model is a river, the drawing is just a tributary. So there might be different kind of clients to your, I mean, different aspects associated. You never know on the BIM project, like on a BIM coordinated project, as to like who's using your model for what. So there's always a chance that someone might have a different interpretation if they don't look at a certain specific set of drawings, because usually production drawings are something that go to the site. It's something that stays in the factory, and then the site would receive the production the marking plans or something for erection purposes. So always I would always advocate that the it's the source of information that needs to be rectified, and it's not the superficial stuff that needs to be tinkered around or maybe tweaked around. So have the drawings are good enough to just tell you that these things are not working, and you can just go back to the model and tweak them, and have your core repository in the right form and order. Because down the line in future, maybe someone goes into the model and tries to tweak things here and there, and it doesn't match it, so it's an entire problem. So it's very important where you fix the problems. So again, the flow of information is from the model to the drawings, and it doesn't work the other way unless there's some BIM authoring tools that do that. And I also like of thinking this as a two-factor authentication, like so in case your model and then your drawing, so based on a certain path, so your drawing have a key, and your models have a certain information. So if that key matches with the information, then your drawings come out correctly. Otherwise, your drawings will show all sort of errors, colors, and all different kind of things. So it's like every time you generate a drawing, if you get a correct drawing, then it could be just signed off to be sent out for production or for review or anything. But if the drawing is coming out with a lot of errors itself, so you need to go and see into it and try to fix up all the issues with that. So this is just basically a concept of checking the models with the drawing generation, because uh, even with all the 3D modeling and 3D review and 3D coordination tools that we have, most of the coordination I still believe is happening on the drawings, and drawings still stay to be an evident form of engineering practices even now. Models they require a lot of software investment and all those things, especially if you want to get a new license or anything for the checking tools that are available. Uh, these templates are easy enough to just be coded. Like someone could just spend maybe a day or something. It would save you a lot of time. Like I personally have felt a great uh, enhancement in my own productivity when I had these drawings telling me that this stuff is wrong. Because even if I would go into the model and use all my comparison and modeling and clash detection tools, I would still have a chance that I would miss out these, data driven things, as well as the comparison stuff that I would usually do. So this is just a concept we did on Tekla structures, but I think this could have a wider implementation as to in Revit and all the other kind of tools as well. I know there's a lot of Excel based validation that's done for Kobe. People would take data off from the models and run some scripts on the on the spreadsheets to know if the data set is correct or what's incorrect, or to find zones and all those things. But yeah, this is just an implementation we did, and yeah, that's it. I hope that talk was something useful, and thanks for being a great audience, and I'd be delighted to have your questions and your comments or views or anything on this. Thank you very much. Cheers to responsible automation.